So sometimes you just refer to the way you solve and the way I solve, right? Sometimes it's good to strategize before you start. So you know that there's no root here. So I don't really want to deal with the root. So I'm going to learn both sides first. Sine plus x. Okay. I think this will be much easier. So you once you've done this, really, this is differentiate. You know that, okay, first of all, know that this is second derivative. So meaning to say, differentiate this twice. Okay, you know that twice you will get this equation. So I'm going to differentiate this with respect to x. Okay, 1 over y dy dx. Then this will be 1 over square root 1 minus x squared, right? Okay. Now, because I don't want to deal with the root, I hate root. Okay, I really do. So what I'm going to do is I am going to just move this to the other side. Then I square both sides. Okay, so my whole equation here, I don't even need to touch the root of the differentiation. So just square both sides here. That's what I'll do lah. But you can, whatever you're doing, it will work. Of course, not an issue. But what I'm trying to get at is in exam, if you try to avoid careless mistake, I don't really like the root lah, the root expression. So I'll usually just try my best to manipulate it. Okay, so this is what I'll do. Okay, so I differentiate this once, then I square both sides so that I can get rid of the root. Then I just do it again. So it's very clean. Okay, so that's what I'll do lah. Just to share some pointers. So this is u. This whole thing here is v. U dv dx plus, so just product rule on the left lor. Okay, so in my whole thing here, I don't differentiate this root equation here. So it'll be u 2 dx this square y dx square plus dy dx. This will be minus 2x equals to, okay, so I just label this down for you. U just like that. So remember this one need chain rule. Just divide both sides by is that what it, okay, nearly close enough. Okay. Okay. First possible will be quite okay. Just go and hunt down all the terms now. That's all we need to do. So x is 0, y is just then dy dx. Do for this one 1 over 1 dy dx is 1 also. Just go and treasure hunt. So you just sub y is 1, x is 0. Oh, so This is also 1. Then second derivative is this one. Then 1 minus 0. dy dx 1 is 1. Okay. So you see that this is how many marks? 5 marks. Quite easy marks in A level. So please adjust your marking system in A level. It's quite clear. Then don't worry about the marks here are pretty much deflated compared to prelim. So differentiate 1 with respect to x. This u v o dv dx. No need to rearrange, just sub the value in can already. Zero, zero, 1, 1. Cool. Okay. This is by successive differentiation. Just bring out the Maclaurin series. Go. One f0 is 1. One also. How do you check your answer in exam? Expansion? Find a way to safeguard your answer. It's not a foolproof method, but it's good enough. So to see whether the your graph work the expansion is correct, what you do is you just key into your graph. You see both graph, just key in exam. They should be roughly around the same. So sine inverse x. Then you key in the one that you found, 1 plus x, x squared over 2 plus x cubed over 3. Okay, so what you are trying to see is that whether the graph touch in the middle here. There you go. Like if it touches in the middle here, like that, so very likely, at least it's not a foolproof method, but at least you can safeguard lah. Double checking. Okay, so this is the exact graph. This is the approximate the curve. So you just make sure you whatever graph you write Maclaurin, just use your GC quickly check.